Good day, dear panelists. I am Jo Marie Marceliano, and together with my team, we will present to you our study entitled Design and Construction of a Portable Floating Hydroelectric Generator with Detachable 24Ah 12 volts DC Deep Cycle Bulb Regulated lead acid battery. Hydroelectric power is a crucial contributor to global electricity generation, constituting approximately 16% of the total mix. It already plays a substantial role in the Philippines, accounting for over 10% of the country's electricity production. This study aims to design and construct a portable floating hydroelectric generator capable of providing sufficient power for charging small electronic devices such as cell phones and powering DC LED lights and fans. In this context, our study will explore the adaptability of deploying the portable floating hydroelectric generator across various water environments. We will assess its performance under different conditions including water depth variations and flow rates. This study contributes to advancing renewable access, educating future electrical engineers, and fostering innovation in the field of hydroelectric generators. The subject of this study is to design and construct a portable floating hydroelectric generator as a power source. This provides an off-grid power source to remote areas and campers to generate electricity to charge their small electronic devices like mobile phones and powering DC LED lights and fans. Components of portable floating hydroelectric generator.
This table represents the time of sunrise and sunset to determine the day length and night length in April 2024 in province of Pampanga. For this next table, it specified the loads and their projected usage hours to determine how many ampere-hour it needs to run for a day. The formula for the computation of average load consumption is given by total number of ampere-hour per day over the total number of days. And to get the maximum load that it can supply, you can divide the average ampere-hour to the correction factor, which is 80%. Shown in this table that includes the time, length, width, and depth of water to determine the flow rate, you can solve it by this formula: width times depth times length over time times the correction factor, which is 80%. As you can see in this table, this is the computed average flow rate for each day and the average generated current. Based on this chart, you can notice that the flow rate has an impact to the generated current. If the flow rate is fast, it can generate much higher current. This formula was used to get the average generated current, the maximum charging time, and the average charging time with respect on the average ampere-hour consumed. Through an examination of the generated current in 10 days, researchers have determined that the average generated current is 1.655 ampere daily. To fully charge the 12 volts 24 ampere-hour battery, it needs at least 14 hours and 30 minutes in condition that the average generated current is equal to 1.655 ampere. The results and data prove that it is crucial to determine the minimum and maximum water flow and minimum and maximum depth of the water to identify the suitable location where it should be deployed. It is proof that portable floating hydroelectric generator can generate enough energy to charge the 12 volts 24 ampere-hour DC lead acid battery under the condition that the minimum flow rate is at least 1.24 cubic meter second, having 0.28 meter as its depth.
Conclusion and recommendations. Conclusion: the study has convincingly proven that the portable floating hydroelectric generator is practical and portable. The generator can charge a 12-volt 24Ah DC lead acid battery efficiently as long as the minimum flow rate is at least 1.24 cubic meter per second and depth is 0.28 meter. After rigorous testing and evaluation, the ability of this generator to operate in such diverse water environments like rivers, tail dikes, and irrigation systems that implies can be used for different purposes in regard to power generation. The research finding also emphasized on the importance of calculating the best water flow rate and depth so as to maximize energy production. In addition to this result from this research contribute to knowledge on renewable energy besides offering recommendation for other researchers intending to innovate and improve the hydroelectric power generation concept. Recommendations. As a recommendation to future researchers coming after the study, as a development design, the researchers of this study strongly encourage to start by understanding the fundamentals of hydroelectric generation, including the flow rate, principle of turbine operation, and energy conversion. For future study, it is recommended to use a higher rating of the generator to generate larger current and to produce the correct power requirement to shorten the charging time of the battery. It is important to know the advancement of renewable energy sources and contribute to the development of affordable hydroelectric system. Also, it is important to use high-quality materials such as anchor, floater, generator, and battery enclosure to make sure the adaptability of the portable floating hydroelectric generator. In addition to this, future researchers could possibly add one more battery to maximize the use of generator.